Assalamualaikum and good day everyone. So we want to see one example on solving a solution to the system of linear equation. Okay, this one is the type of your test and final questions. Okay, so let's see example here. Using Gaussian elimination, determine the value or the values. Okay, it might be have one value only, or you can have many value of k, so that the system of equation fulfill this condition. Okay, or fulfill all the equation here. Okay, so what you want to do is you want to find the value of k here. Okay, so that your system has no solution for A. For B, your system has unique solution, and for C, your system has infinitely many solution. Okay, so what the question asks you is to find the value of k so that your system fulfill all of these condition. Okay, so as we discussed before, the first step you need to do is you need to transform the system of linear equation into the matrix form. Okay, so let's write this one in form of matrix. So we have the coefficient matrix here. Okay, and we have the variable matrix here equal to the constant matrix here. Okay, so for the coefficient matrix, you have 2, 1, negative 7. You have 1, negative 3, negative 7. And you have 2, negative 1, and negative k square plus 5. How do you know this one is the coefficient? Because this one is the variable. Therefore, the rest is the coefficient of that variable. Okay, so you have a variable here. Your variable is x, y, and z. And you have a constant negative 1, negative 2, and also k. Okay, so if you can see here, you have b not equal to 0, means we have a non-homogeneous system. Okay, so next, what you need to do is you need to write this matrix in the form of augmented matrix. Okay, so let's write this one: 2, 1, negative 7, 1, negative 3, negative 7, 2, negative 1, negative k square plus 5. Okay, and you have the constant negative 1, negative 2, and k here. So this one is your augmented matrix. Okay, so what you need to do before we can decide on the value of k to fulfill all the conditions set here, okay, is to reduce our matrix in the form of row echelon form. Okay, so we need to reduce this matrix into row echelon form first. Okay, so let's take this one. Okay, so we want to reduce this one to row echelon form. So what you need to do is you need to make this element to become 1. Okay, so what you want, how to make these two become 1 is just simply to divide all element in row number 1 with 2, because 2 divided by 2 is 1. We focus for this element. Okay, we just focus for this element. We want it to be 1, so 2 divided by 2 is equal to 1. Therefore, we will get the new matrices here. Okay, and it only will change the row number 1. So row number 2 and 3, you just copy back. 1, negative 7 here, negative 3, negative 7 here, negative 1, negative k square plus 5 here. Then you have negative 2 and k here. So all element in row number 1 divided by 2. So 2 divided by 2 is 1, 1 divided by 2 is 1 over 2, 2 divided by 2 is 1, negative 1 divided by 2 is negative 1 over 2. Okay, next, we discussed before, after we got the leading one, we need to make sure all element below it must equal to 0. So we need to change these two elements to become 0. So we need to change row number 2 and row number 3. Okay, so what we need to do to make sure that two element become 0. Okay, so for row number 2 is simply you minus this one with this one. 1 minus 1 will become 0. Therefore, to get the new row number 2, you will minus with row number 1. And to get new row number 3, you want this one to become 0. So negative 7 to be 0, it might plus with 7. So how can you get 7? You need to multiply row number 1 with 7. Okay, so row number 3, you will add it with 7 times row number 1. Okay, so it will change row number 2 and row number 3. Therefore, row number 1 will remain the same. You just need to copy back 1, half, 1, negative half. Here row number 2 minus row number 1. So 1 minus 1 is 0 here. Negative 3 minus 1 over 2. Negative 3 is negative 6 over 2 minus 1 over 2. You will get negative 7 over 2 here. Negative 1 minus 1, you will get negative 2. Negative 2 minus negative 1 over 2, you will get negative 3 over 2. This one you can calculate with calculator. Okay, and then now we want to change row number 3. Row number 3 must be add to 7 times row number 1. So let's find first what is 7 times row number 1. So 7 times 1 is 7. 1 over 2 times 7 is 7 over 2. 1 times 7 is 7. Negative 1 over 2 times 7 is negative 7 over 2. So we add negative 7 plus 7 is 0. Negative 7 is negative 14 over 2 plus 7 over 2 will give you negative 7 over 2 here. Negative k square plus 5 plus 7. Okay, negative k square plus 5 plus 7. Okay, so you just need to write this one because we cannot solve this one, so just write it. Negative k square plus 5 plus 7. Then k plus with negative 7 over 2, you will get k minus 7 over 2 here. Okay, so now if you can see, the element below the leading one have already been equal to 0. Okay, so here he's leading 1 and below leading 1 is equal to 0. So we have done. Okay, next we want to change this one to become 1 because we want it to be a leading 1 for row number 2. Therefore, how can you do so that this negative 7 over 2 will become 1? Just simply by multiply it by negative 2 over 7. Okay, negative 7 over 2 multiply negative 2 over 7, you will get 1. Okay, therefore, now you will change row number 2. Row number 1 and row number 3 will remain the same. So we just copy back. Row number 1, 1, half, 1, negative half. Row number 3, 0, negative 7 over 2, negative k square plus 5 plus 7, and k minus 7 over 2. Okay, so row number 2 multiply with negative 2 over 7. 0 multiply negative 2 over 7 is 0. Negative 7 over 2 multiply with negative 2 over 7 is 1. Negative 2 multiply with negative 2 over 7 is 4 over 7. Negative 3 over 2 multiply with negative 2 over 7, you will get 3 over 7 here. Okay, so now we already have leading 1 for row number 2 here. So we need to make sure below leading 1 is equal to 0. So we need to change row number 3 now. So how to do so that row number 3 will become 0? You just need to plus row number 3. You need to plus it with 7 over 2 row number 2. Okay, so now the row that we change is row number 3. So row number 1 and row number 2 remain the same. 1, 0, half 1, 1, 4 over 7, negative 1 over 2, and 3 over 7 here. So this one is the same. Okay, so now what we do is row number 3, we will add it with 7 over 2 times row number 2. So let's find what is 7 over 2 times row number 2 first. So 7 over 2 times 0 is 0. 7 over 2 times 1 is 7 over 2. 7 over 2 times 4 over 7 is 2. 7 over 2 times 3 over 7 is 3 over 2. Okay, so now row number 3 you add with this one. So 0 plus 0 is 0. Negative 7 over 2 plus 7 over 2 is 0. This one plus this one. So you need to write negative k square plus 5 plus 7 plus 2. So it becomes negative k square plus 5 plus 9. So here you have negative k square plus 5 plus 9. then k minus 7 over 2 plus 3 over 2. So k minus 7 over 2 plus 3 over 2 will give you k minus 4 over 2. So k minus 2. So here you have k minus 2. Okay. So now guys, you see, we have done with all the element here to become row echelon form except these two elements. Okay. And these two elements play the important role, okay, so that your system will have either no solution, many solution, or unique solution. So if you can remember, we discussed last time, for us to have no solution, okay, the element here must equal to 0 and the element here must not equal to 0. It must fulfill these two conditions so that you will have no solution. Okay, so now the question asks you to find the value of k so that your system will has no solution first. So what we need to do is we need to make sure this one is equal to 0 and this one is not equal to 0. So let's write our equation here. So we have negative k square plus 5 plus 9 equal to 0. And we have k minus 2 not equal to 0. Must fulfill because we want our system to has no solution. Okay. So now we just need to settle this one. Positive 9, bring here, it become negative 9. So you have negative k square plus 5 equal to negative 9. Negative and negative you can cancel out. So you have 3k square plus 5 equal to 9. Plus 5 bring to the right, you will get negative 5. So k square equal to 4. Therefore k will be positive and negative 2. So you have two value, k equal to 2 or k equal to negative 2. Okay. Let's check second condition. K minus 2 cannot be equal to 0 because you want your solution to have no solution, your system to have no solution. Therefore, you bring this one to the right, you will have k not equal to 2. Means that your k cannot equal to 2, so we cancel this one. So, your value of k is equal to negative 2. Therefore, your system will has no solution. Okay. Question asks us to find the value of k so that the system will has a unique solution. Okay, so we come back to our row echelon form here. This one is row echelon form. So, for our system to has unique solution, okay, for our system to have unique solution, for system to has unique solution, your element here must not equal to 0. Okay, must not equal to 0. Okay, so when you have solution must not equal to 0, now we take this equation. Okay, so negative k square plus 5 plus 9 must not equal to 0. Okay, so we just bring the positive 9 to the right, you will have negative k square plus 5 must not equal to negative 9. Then negative and negative you can cancel out, so you have k square plus 5 must not equal to 9. K square plus 5 must not equal to 9. Okay, so you bring positive 5 to the right, you have k square not equal to 9 minus 5. K square not equal to 4. K square not equal to, k is not equal to positive and negative 2. Means that for our system to has unique solution, we can have any value of k, but it cannot be equal to positive 2 and negative 2. Okay, because positive 2 and negative 2 will give this one equal to 0. We cannot have that one is equal to 0 to have a unique solution. Okay, so you just left your answer like this, or you can write k not equal to 2 and k not equal to negative 2. Okay, means that you can have any value of k but not positive 2 and negative 2. Okay, this one for unique solution. Next, question asks the value of k so that our system will have infinitely many solutions. Okay, so we come back to our row echelon form here. So to have infinitely many solutions, this element must equal to 0 and this element must equal to 0. Okay, so we just write negative k square plus 5 plus 9 equal to 0. Okay, and k minus 2 equal to 0. Okay, so negative k square plus 5 equal to negative 9, k square plus 5 equal to 9, k square equal to 4, k equal to 2, and negative 2. This one means that you have two value of k, but don't forget that you have another condition here, k minus 2 is equal to 0, so k is equal to 2. Okay, so means that you have to choose k equal to 2, therefore you will have many solution. Okay.